how Japan's internet started illegally. We've watched some other, like, Japan tech videos. I think this one could be fun. We watched one about... Sorry, no, we didn't. Yeah, no, I think it was part of the Mandarin video on, like, on Japanese typing. So this one should be fun. I've never watched a video from this channel, so yeah, let's check it out.
I'm standing here at the Tokyo Institute of Technology. On this very site in 1984, a group of researchers illegally started the modern Japanese internet.
And then uploaded hentai immediately.
Led by one man, Professor Jun Murai, he had to physically bring back modems in his luggage from the United States to get the connection up and running. This unauthorized network not only transformed Japan, but also made the global modern internet possible. Let's talk about the complicated history of the internet here in Japan, and how one man, the internet samurai, helped pave the way for the
No, that's not... Okay, I love... Yeah, sure.
Open internet we have today. To start the story, though, we need to go back to the 1980s.
That was before I was born. That's when Yakuza 0 was.
At this point,
that's what I know about
was
the
a
80s.
technical powerhouse. Sony, Panasonic, Toshiba, Hitachi were revolutionizing consumer.
I always forget about Hitachi. Hitachi is such a fun company because Hitachi is they're like Remington, Remington, where you probably know, or LG, where you probably know the name Hitachi. You know why you know the name Hitachi. Or like Remington, you probably know for their shotguns. But like, they also make like electric razors. And Hitachi makes air conditioners as well. They basically make anything electrical.
Electronics. Japan was dominating the global semiconductor supply, holding about 50% of the world's market for memory chips.
Wow.
Personal computers were
and now OpenAI holds 50% of the market.
Becoming prevalent. Commercial Unix was rapidly gaining popularity among researchers abroad and in Japan. Given this manufacturing dominance, you would think Japan would be leading the charge for interconnectedness and networking, right?
No,
this
Japan.
was not the case. They were years behind.
Sorry, what the Sorry, what are we looking at here? I'm assuming this is like is this like a dial-up modem? Or is this a phone integrated into a computer? I'm not sure what this is. I don't know what the fuck I'm looking at. My first Hitachi fridge was from 1970. The first second 20 years present. Hitachi makes electric back massager, nothing else. Yes, very much back massager.
In the rest of the developed world.
It's important to know across the globe there wasn't just one internet at this point, but many different networks all competing for dominance in many different domains.
In the United States, the primary network, ARPANET, had just been split in 1983, creating a separate network for the military called MILNET.
Oh.
Globally, other
what a great
countries
name.
were building their own networks too. France had its Minitel system that they were doing some interesting stuff with at this time. The EU had EARN, UK had JANNET, and Korea had SDN, launched in 1982. Now networks that connected central computers and allowed remote log launched in
literally 1984.
1982. Now networks that connected central computers and allowed remote login were over a decade old. What made these new networks exciting were new protocols that allowed cutting-edge communication features such as email and newsgroups. These were revolutionary for researchers who previously relied on the mail and very expensive long-distance calls to communicate. The problem for Japan was these networks were illegal.
The Japanese telecommunications industry was under strict control of a government-run monopoly, Nippon Telegraph and Telephone Corporation, or NTT. Under Japanese law, NTT were the authorities and the only ones allowed to connect modems.
NTT. That sounds a lot like AT&T. And probably acts in a very similar way at the time.
To telephone lines.
This meant there were only 2 real multi-site networks in the country. NTT's own internal network, DDX, and a legacy mainframe network called N1, which was strictly for file transfers and remote logins of central computer resources between universities.
One letter away from NTR. Ooh.
This is where Jun Murai comes into the picture. As a young researcher, he actually helped set up the first network here at Keio University's Yagami campus. He actually physically ran some of the networking cabling himself, having to go under the university through a manhole cover that is apparently famous that I'm not able to find. Trust me, I looked all over this campus. I can't find this manhole, or I'd be standing right over it right now.
But in the early 80s, he had moved campuses, and he'd become frustrated with how difficult it was to transfer information and communicate with colleagues at his previous university. In 1984, while government officials were still debating regulations and discussing which open system interconnection architecture to adopt, Murai decided he didn't want to wait. As he later recalled in a 2021 interview, "What I wanted was to have a network, to do actual operation and development, so that we can find out what the problems related to computers and communications were, then solve them." He continued.
Yeah, he didn't want to deal with, like, business problems. He actually wanted to deal with, okay, what are the actual technical issues with building a large-scale network? The business bullshit, that's all stupid. Don't worry about it. Who needs regulation?
By an early career researcher such as myself, the feeling that I was doing something forbidden was compelling.
Aha.
In October of 1984, Murai and his colleagues used those modems I talked about earlier to connect Keio University to here, Tokyo Institute of Technology. This was only a 300-bit line, and it wasn't a network as there's only 2 universities connected, so they quickly connected the University of Tokyo with a 1200-bit line, and now with 3 distinct locations.
1200 total bits. Wow. You couldn't even render this entire frame with that.
They had a network. They called this network JunNet. Now, this JunNet was not for Jun Murai, the creator, but actually Japan University Unix Network. The Unix here stood for the protocol it used, UUCP, which was popular at the time in the United States.
Unix to Unix Copy Protocol was a suite of programs that allowed Unix systems to exchange files, execute commands remotely, and, importantly, transfer emails.
Oh, Twitch chat's frozen? There you go.
And Usenet News. Originally developed right next to Unix at Bell Labs in the late 1970s, UUCP became the backbone of the early computer networking before TCP and IP took over. Later references later dropped the Unix from the JUNet acronym, later referencing it just as Japan University Network, probably due to the network later experimenting with other protocols beyond UUCP. Although creating JunNet was risky, the timing was perfect. Just a few months after launch, the Telecommunications Business Act was passed, liberalizing the industry. The law that made JunNet illegal was overturned. But this was not Dr. Murai's last clash with regulators to bring the internet to Japan.
Now that we have a connection, though, it's important to note that networking was only half the battle. The other half, the Japanese language. Lacking a bit of foresight.
Yeah, this is probably related heavily to the... Well, obviously by this point, they're already be able to type. But that doesn't mean that people outside Japan would be able to decode that information.
Internet protocols were built for English.
They use 7-bit ASCII, which supports 128 characters. That's fine for the Latin alphabet, numbers, and some punctuation. It's not fine for kanji, which has thousands of characters. There were 2 hurdles here, both input and transmission of those characters. Starting with input. Dr. Murai had actually already tackled the issue of input in 1982 with a system called JIS-DOS. It allowed users to type phonetically using katakana or romaji, and then the computer would convert it into more readable kanji. Around this time, other Japanese researchers were also creating other systems to work with Japanese text, such as K14, a kanji font system that actually allowed operating systems to render that kanji onto the screen. And there was software being ported such as K-Term, which was a clone of a popular important X-Term terminal emulator.
You don't understand how big X-Term used to be. So, going back just to like 2011, 90% of Arch users had X-Term installed. X-Term at a point was the terminal emulator people used. And other things existed, sure. But up until, like, the mid-2010s, like, maybe close to 2018, 2019, it was, like, frankly, just better than everything else out there. Yeah, it didn't have the fanciest borders or anything, but it was fast. However, when things like Alacrity came along, when things like Kitty came along, and it had GPU rendering, it had true color, it had a bunch of other nice features, Xterm just fell off a cliff, because Xterm is amazing, and Xterm is great for dealing with compatibility with old systems, but it doesn't bring in a lot of the modern stuff now that those old systems are not really in service anymore.
The era. But transmission was harder. Unix is written in C. The character data type in C was only actually 8 bits. Mirai explained in a TED Talk he gave a few years ago, he actually confronted Dennis Ritchie, the creator of C, about this oversight. But email was even worse. It was strictly 7 bits because it used ASCII. If you tried to send sophisticated Japanese kanji through a 7-bit email pipe, the data would be corrupted. So in October of 1985, the JUNet team got clever. They developed an encoding method that was 7-bit clean. Basically, they used specific escape sequences, or codes that told the computer, hey, the next few characters are actually not English, but kanji. This allowed them to tunnel the complex Japanese text through the existing limited English infrastructure. Mirai published this as an RFC to the IETF. This was a massive milestone, not just for Japan, but it helped set the precedent that the internet shouldn't just be for English speakers.
So now that you had a network and a way to communicate not just over English, what could you do on JUNet? Well, this was 10 years before the World Wide Web, so outside of basic file and resource sharing, you had email and news. But neither worked the way they do today.
Email was clunky. You couldn't just send to an email address. No. You had to know the complete route through the network ahead of time. In this example, pulled from the book Broadband Deployment in Japan, the email is being sent to user June on host Titka through Cosfax from user
Titka.
Kovacs. This, of course, was clunky, and in May of 1985, they quickly moved to a hierarchical domain name system where root nodes knew the whole network topology. Cutting edge at the time, and they used the top-level domain JUNet. This was the first time for a UUCP-based network, and the system they started quickly became the standards for others globally. But being this national network, it grew out of the JUNet domain, and according to the Internet Hall of Fame, Mirai came up with the first concept of country-specific domain names, or CCTLDs, now commonly used around the globe. It was later delegated .jp from Dr. John Postel as a test case of domain names to be assigned to countries and geographic regions like Mirai was proposing.
Yeah, I was gonna say, that didn't make any sense.
These elements working in conjunction made email look much more like they do today. Next was news. JUNet created FJ news groups, discussions and forums that could only be seen in Japan.
In 1986, JUNet got a massive upgrade in the form of a connection to the United States and CSNet. This meant for the first time Japanese researchers could email and get news from not only the United States, but around the world.
Cool fun fact, this was all initially done through satellites, but a few years later through the Pacific Communications Network, or PACCOM. They used a connection through Hawaii, and then later the first undersea fiber cable across the Pacific, called Transpac 3. And they made a 6 stamp. By the late 80s, Japan was now truly connected with the world's networks, and JUNet was a true national network. It was volunteer-run, with each institution paying its own connection costs using a mix of telephone dial-up lines, early Ethernet connections, and X.25 packet switching, an early packet switching protocol that probably deserves its own video.
By the late 1980s, JUNet had grown to over 220 organizations, but it still used dial-up as its backbone. Because they were using the standard phone lines, that meant cost scaled with every single connection, which the JUNet team learned as one faulty email attachment got bounced over the Pacific Ocean multiple times. They got a very costly bill.
And many other networks around the world were switching to the more flexible TCP/IP. But TCP/IP was not the protocol the government had in mind for this future.
Of course it wasn't, because the government always has great ideas. Every single country, the government has great ideas that are so much better than the engineers Don't listen to those stupid engineers with their stupid engineering problems. No, I am the business guy. I know the real solution.
National network. Japanese government authorities were pushing for the competing Open Systems Interconnection, or OSI. That was what they argued the official international standard and what Japan should be using. This did not stop Mirai and his colleagues. They pulled together some money to start the WIDE project, Widely Integrated Distributed Environment, a consortium of companies, universities, and public institutions. WIDE's goal was to research and develop wide area communication using TCP/IP, the protocol that we still use today.
I've seen these graphs a million times. I have never seen this graph with Japanese this diagram with Japanese text. No, we've moved on to Reacts. We're learning about the Japanese internet.
They also switched to faster and, importantly, dedicated digital leased lines.
Of course, this put Mirai at odds with government authorities who were trying to make their own organization. This organization was building a competing network to JUNet and WIDE using government-approved and government-controlled protocols.
Mirai believed that real-world testing and development...
How do we go the entire stream with no disconnects? And then as soon as we get to Reacts, we have 3 of them in 30 minutes. How does this happen? I do not understand. This makes no fucking sense.
Was more important than waiting for official standards, and he continued to move forward with his work on WIDE and TCP/IP without this government approval. Mirai's gamble paid off, and the global networking community rallied behind TCP/IP over OSI. And WIDE's TCP/IP-based backbone later became what Japan still uses and what became the actual Japanese internet. But there was a problem brewing with how Japan was using these networks, or more importantly, not using these networks.
By the early 1990s, Japan had fallen significantly behind. In 1993, they had about only 1 for every 20 networks the United States had. And if you looked at the popular research network, NSFNet, Japan's outgoing traffic was about 42,000 megabytes per month, which was barely that of Taiwan's that had 1/6 the population, and only half that of Australia's.
Japan was the world's second largest economy at the time, and the internet was becoming a great economic tool abroad. But Japan was not using it at the same rates. Not for lack of interest, though. By 1992, WIDE had become so popular that Mirai was forced to turn down new connection requests. But it was an academic network at the time, and commercial use was not allowed.
So Japan didn't have, like, commercial public internet yet.
The issue was, again, the Japanese government's slow response to the moving trends. There were restrictions on the creation of corporate internet service providers, and none existed because of these restrictions in the country. Mirai's solution, again, do it himself. In 1992, he founded the Internet Initiative Japan, the country's first commercial ISP. But IIJ was limited in that it could only provide domestic services, and to open a connection to international traffic, the Ministry of Post and Telecommunications had to grant a license, which became a challenge. As a 1994 Wired article described it, Mirai and the freewheeling democratic style of the internet has run smack into traditional Japan at its most authoritarian. In the application to get the operating license, Mirai had written passionately about his experience with experimental computer networks and the technical capabilities they had. But what the ministry wanted was a bank statement. As Mirai and his colleagues expressed, the bureaucrats couldn't understand that the internet wasn't being built for profit. It was being built for openness and communication, and Mirai and IIJ didn't get their operating license.
Japan's first commercial international internet traffic was being transmitted not by Mirai or another Japanese ISP, but a subsidiary of AT&T, an American company.
I mentioned AT&T earlier. I didn't think they'd actually come up in this. AT&T even took over Japan.
This was a clear sign to the Japanese research community to stay in their lanes.
Around this time, many early internet researchers outside of Japan had successfully made the jump to the corporate world, but Japanese researchers did not. As a result, even though Japan had lower internet adoption through the 90s, because of the abundance of researchers staying in academia, Japan began to assume a central role in internet research. Mirai and the WIDE project continued making contributions that would shape the global internet, and at the time, this new emerging World Wide Web. For example, Japan continued their lead in innovations related to the internationalization of browsers and email to facilitate the use of languages other than English, like they did in the era of JUNNet. In 1996, WIDE operated the first IPv6 line between Tokyo and Nara. IPv6, that we have talked about to death on this channel.
IPv6. Okay, yeah, let's talk about IPv6. You know, we ran out of IPv4 addresses 20 years ago. We still haven't adopted IPv6 entirely. There's still a migration to IPv6.
Had success partially due to the significant efforts by Japanese researchers through the WIDE project. They were the ones that integrated IPv6 into important Unix distributions of the era. Then in 1997, WIDE into
important Unix of the era, not Linux just yet. Not Linux.
Important Unix distributions of the era. Then in 1997, WIDE launched probably their most visible global contribution. They began maintaining the mRoot DNS server, essentially running some foundational infrastructure of the internet, one of only 13 servers around the world, only 3 of which are actually outside the United States. The tech you use interacts with these servers every day, and they are some of the only centrally controlled internet resources in the world, which makes WIDE's efforts here and responsibility critical and important. In this time, Mirai continued establishing himself as a defender of the global and open internet. He was a founding board member of the Internet Society, established in 1991 to make it easier for foreign governments to accept protocols and standards being developed by researchers. Dr. Mirai said, "I was thinking that Japan kind of came as a first trial. I really hope that by following this, other countries joining the internet would not suffer the extreme difficulties that I experienced." He was also one of the 9 initial directors of ICANN, the Internet Corporation of Assigned Names and Numbers, which governs domain name system today. And he had involvement in leadership in many other internet organizations that have a wide range of impacts to the internet today. Mirai himself, now in his 70s, is still out there advocating for a free and open internet and what it can do for the Japanese people and the world.
Wait, he's only in his 70s? He's been around for a while. I thought he'd be older than that.
In recent news, Mirai and the WIDE organization are actually sitting on about $300 million worth of IPv4 addresses, or the whole 43/8 block that they're now selling to help fund and assist the boosting of Asia-Pacific connectivity.
Mirai's refusal to bow to the system, his commitment to openness over control, and his
Linux,
technical vision
He's
not
a Mac
only
user.
brought Japan the internet, but helped the internet become a global, open, multilingual network that it is today. If you enjoyed this video, check out my video on why downloads look like waves, a lot of early internet topics like this video. Otherwise...
That was a good video.
Subscribe, like, comment, you know, all the stuff. So any way that you could support is super helpful. As you can see, a little bit more involved than my videos normally are. So
Leave that videos on his channel?
of course.
He's only got 18k subs. What else has he got? IPv9? What? Okay. A forever website. Downloads looks like waves. Oh, and he's just got, like, Linux tutorial videos. Wait, hold up. This guy
I want to go through practically.
This guy literally just started doing, like, regular old Linux tutorial content. And then he's just like, you know what? That's boring. I'm gonna do, what do you call, like, video essays. You know what? I respect that. I absolutely respect that. And he has an email address there. That's cool. No, that was a good video. Definitely have to check out more of his stuff in the future.